Okay, welcome to MSUA Game Changers webcast, where we speak with satellite and mobile connectivity thought leaders about industry trends and share what you need to know about the future of mobile satellite communications. I am your host, Roger Lanto, and I'm excited to introduce Rob DeMillo, co-founder and CEO at data space infrastructure company Sophia. At Silicon Valley Space Week, we learned that the data storage industry is looking at $7 trillion of committed investment over the next few years, with even more money funneling in the years beyond, at least according to our friends at McKinsey. To meet this challenge, which comes with power management and cooling requirements, category leaders are looking to the stars and the seemingly limitless energy and cooling resources that exist there. We want to know how real this all is, and Rob is going to walk us through it. Rob? Welcome. Did I get your last name correct? I didn't ask.
Yeah, that's close enough. First of all, Roger, thank you for having me on. My father would say DeMillo. DeMello is what everyone does, so I just go to DeMello.
Okay, and shame on me because I have a challenging name. So tell me a little bit about your history and connection to the satellite industry.
Yeah, sure. So I started my career, and unfortunately I have to give my age away to do this. I started my career back in the 80s. I was at Jet Propulsion Laboratories there. And I was initially, I was the image processing specialist for the Galileo spacecraft and Mars Observer, God bless its soul, and the Soviet Union's Venera spacecraft, just to give you some idea. And then I left after about 7 or 8 years, and I went to work for the FAA via Lincoln Laboratories at MIT, and it was doing basically the same work, but it was in the radar spectrum. And we built terminal Doppler weather radar, which I think to date is still the FAA project that was on time and under budget, so you can get to score a check mark there. We turned that over to Raytheon for productization, and two of the vendors that I was using at TDWR were spinning out a startup company. They asked me to go with them, and I did. And that began a 30-year-long career of doing entrepreneurial work. So I started in the media space, basically. So video production, video distribution, computer graphics, computer animation, special effects. And that led, if you follow the Trail of Tears, it led to data centers pretty quickly. So I was... the last 15 years of my career has been in cloud computing and data centers. And the last company that I sold was a company called Nimble Collective. I started it with a bunch of luminaries from the computer graphics industry, the folks that did Toy Story and Gollum from Lord of the Rings and those folks. And we moved the animation workflow platform up into the cloud. We had a cloud agnostic solution for doing this. And then we got bought by Amazon. I essentially went into sort of a soft retirement at that point, and I got a call last summer. And I got a call last summer from a startup venture studio called Mandala Space Ventures. And Mandala Space Ventures was started by a guy named Dr. Leon Alkali, who's a 33-year veteran at JPL, ex-fellow from JPL. And he left to start Mandala Space Ventures to promote space technologies. And so Mandala called me first, and then eventually, Leon on the phone. And we started talking about this. And we talked on the phone for about 5 months. And in December, I agreed to come on board. And in January, I took the helm. That's about as Reader's Digest as I can make it, Roger. So.
Well, it sounds like you've already answered my next question, what was the genesis of Sophia?
Not quite. So Leon actually, this was his baby. He was the one that was the brainchild of this. And so Mandala Space Ventures and JPL and Caltech in the early 2020s was given a grant to study the feasibility of collecting solar power in space and beaming it back down to Earth. And after 18 months of study, the math worked out. It would work, but they couldn't make the finances work out quite right. So as they were taking the study apart and shelving everything, Leon raised his hand and said, "What if we put a server on this?" And that's the Spider-Man origin story for Sophia. So it's been kicking around Mandala for a few years, and it finally got to the point where the tech could support the vision and the marketplace could support the tech. And that's when they started taking it seriously, and they called me up and we started it. So,
and are we talking in orbit or on the moon or both? Or
no, we're talking about in orbit. So the idea behind Sophia is a fascinating one. We call ourselves a orbital compute company. The end goal is orbital data centers, which I realize that's what this specific episode is about. But on the way to orbital data centers, we are taking our compute units and selling them directly to our clients. So what we have done is we've developed a device that we're calling a tile. And a tile is a 1 meter by 1 meter by 1 centimeter object, a completely solid state. And it takes in solar power at the top of the tile. That solar energy is, well, after you do the conversion, you wind up with enough power to power a CPU and GPU layer underneath the hood, all of which have been laid out flat. And then the heat generated by the CPU and the GPU go to essentially a backplane radiator that allows it to radiate out into space. So that's the primary unit of what it is that we have created. And we are selling them directly to the clients in units of a rack. We call the term a rack for a reason. It denotes the connotation of a rack of servers in the back office. And you can buy them in any configuration. And then they can be connected to the armature of the spacecraft or the station or the satellite or the infrastructure that needs the compute capabilities. And for companies that have satellites and stations and infrastructure that can't support an armature for one reason or another, we have another line item that we're calling a Sophia companion satellite. And a Sophia companion satellite is simply racks with a communications hub on it to allow optical communication to the host. So those are the first two incantations of what it is that we're doing.
So it does sound like the different players that are emerging in this space are taking different approaches, and
Yeah.
we just met at the Silicon Valley Space Week, and we had a keynote that very forthrightly presented this prospect of servers in space, and had a little bit of skepticism expressed by another keynote speaker at the event.
Yeah.
So how do you sort of make sense of these conflicting views in the context of this overwhelming message from McKinsey?
Well, I get the conflict, right? So until very recently, we've successfully fundraised to date, and we're still fundraising now, but until very recently, this was considered science fiction, and by very recently, I mean in the last few months, right? And so there's a mind share lag that happens, I think, in a lot of folks' heads as they look forward. And looking out into the future, and so they're still kind of hanging on to these ideas of this is a very difficult prospect, and it is a very difficult prospect, right? So the biggest issue in orbital computing has to do with cooling, right? So space is basically a thermos, right? You're in a vacuum, and the only way to relieve heat pressure is to radiate it out, which is hard to do. We have solved that problem. We know we have, right? Definitively we have. So for us, that challenge became our greatest strength. But there are folks out there that are still naysaying this because it doesn't feel like a thing that can be done or be done very easily. But if you look at the economics of it, not bad, right? Like if you're building a data center on Earth of a certain size, there's a certain capital expenditure over a given length of time. And there's both CapEx, which is the money that you spend to build a physical thing, and there's operational expenses, right? So power and heat and light and cooling and people, right? And when you start talking about data centers in space, the CapEx kind of balances out, honestly, with the terrestrial data centers. But what gets lost in the process is OpEx. It's much different. It's a much different OpEx component to what it is that we're doing. So there's a lot of stuff to put in the blender and kind of understand as you're talking about computing in space and orbital data centers in general in space. And so the naysayers are there, but a lot of stuff has happened recently that is showing the naysayers the way, and we're not alone, right? Just in the last couple of weeks, you saw SpaceX make an announcement about this, and Google make an announcement about this, and we were an article with.
What was there was the announcement from Google just this week, and
Suncatcher. I think they're calling it Suncatcher, right?
Yeah. So what was the implication of that, or what was the nature of that?
They're shooting towards data centers. So it's they've embraced the idea, and it's right now it's one of the Google moonshot ideas, in this case literally. But they're putting machines in orbit to do something very, very similar, and we love it. It is good for us, and it's good for our competition actually. That all of these other companies are getting involved in this, because it shows market viability, and it shows the need and the desire. So there's a lot of interesting things going on right now. So I did this with somebody else, so I apologize if you've all heard this before. But what's happening in low Earth orbit, LEO, we call it LEO. What's happening in low Earth orbit is a build out of an infrastructure that is not dissimilar from building out a smart city. So you have a number of companies taking place in this world building, right? And so there's folks building out the infrastructure, and they're building out the communications pipelines, and they're building out the compute pipelines, right? Us, and there's a lot of stuff going on, and the reason has to do with rapid drop in launch costs, right? So it wasn't that long ago, about 5 or 6 years ago, where it was $55,000 a kilogram to get something into orbit, and now it's I think I forgot to check the pricing this week, but it's like $3,000, a little bit more than $3,000 a kilogram. And it's not that long from now, it'll be under $1,000 a kilogram. And you can think of this as, I always get eye raises about this, but you can think of this as what it was like in the American West, when it was very difficult to go from town to town, right? There were just goat paths everywhere. And so you had horses and wagons, and it was an expensive endeavor to go from, Chicago to San Francisco, and then paved roads started showing up. Right, first trains, of course, but then paved roads, and paved roads allowed you to build machines that could travel those roads, right? And prices started to drop on those things, right? And you could suddenly get people and merchandise and goods and wares back and forth, and I draw that analogy because that's exactly what's going on right now. It was hard to get to orbit. It was hard to maintain orbit. It was hard to do things in orbit. That's not true anymore. It's becoming less true the more we sit here and talk about it.
So when I have a question here about, what the reception has been. So what I'm hearing is the reception has warmed over time as the launch costs have come down.
Yeah. The reception's warmed over time now as launch costs have come down. The reception's warmed over time as people start to see the need for what it is that we're doing. So there's a lot of conversations that a lot of folks have to connect the dots between launch costs and what's happening right now, but which they're doing successfully. But the reason the reception has been getting warmer is because the need for what we're doing is becoming apparent. And, we're starting out, as I said, the first part of our life, we're building these tiles and we're selling them as racks and individual satellites to our clients, which deals with edge computing, because there's a lot of edge computing requirements for orbit. Well, we are on the path for creating a Sophia orbital data center, not too much further down the road, actually. And when people start talking about orbital data centers, when they were talking about it in January, it was kind of an eye roll. And who wants that? And as time went on, that idea changed, and people began to see what was going on. And the number of terrestrial data centers that we have right now on Earth isn't enough.
That's a pretty short time frame for such a radical evolution.
Yeah, it is. But it's things happen fast in a small Western town, right? So it is, but we're living in an age of something that didn't exist last week exists this week, right? AI chatbots are suddenly everywhere, and people just accept them as
And,
reality. Whereas
now
2 years ago, that was not the case.
and I'm assuming the data uplink downlink is an important piece of this proposition. Yeah.
Not as important as you think. So it will be. So by the time we get to the orbital data center phase, yeah, but there's going to be a lot of options when that kicks in. Right now, what we're doing is we are by doing edge computing in orbit, we are relieving the pressure on uplink and downlink. So think what's going on right now. We have these amazing satellites in orbit that collect terabytes or petabytes of data a minute, like seriously, like really intense things. They throw most of that data out because they have to ship the data down to the planet to do the processing, and then it's either used somewhere on the planet, or if the satellite has to take action based off of that data, it has to get sent back up. So if you think about things that way, you can't do a lot of stuff in real time, right? You can't do missile tracking, really. You can't do air traffic control. You can't do maritime tracking. You can't do environmental catastrophe tracking, right? But now you put a compute platform in orbit, and suddenly you can, right? The same way that you have rapid computing and edge computing here on the ground, you'll have edge computing in orbit. And it's not limited to those example sets that I've said, by the way, but that's so people are seeing that.
So what is the role of government in the evolution of this opportunity, and also the military? And I'm coming at that from a couple of different ways, because sometimes you have a solution and you explain to the military, this is what we can do for you. And then other times the military says, we want to do these things. How can you help me do these things? Or we have an RFQ.
Yeah,
but
both those things are happening and in play, right?
Okay.
And obviously, the Department of Defense has a lot of interest in this sort of thing, a lot of interest in edge computing in orbit, and down the road, data centers in orbit. So that is conversations that, we'd be lying to you. I said they weren't going on; they are going on. But what's equally interesting, or depending on the lens you're looking through, more interesting, is the commercial side of this. Right? There's a lot of companies are saying, wake up to the fact that, there's a lot we can do, and there's a lot of interest that we can take in doing all this. So there's a kind of a handshake going on between defense activity and commercial activity.
Classic dual use, yes?
Classic dual use. That's exactly correct. Yeah.
But is either one sort of, leading the way? I mean, I think of commercial as leading the way, but then all of a sudden, the government has a,
Yeah, it depends. It really depends. It really depends on how you look at all this, and who you're talking to and what day you're talking to them on. So the dual use case, like you joked about it, but it's true, right? One of the things that pops out of all this when you have orbital data centers is a sense of security, right? It's a secure installation, just from the point of view that nobody can drive up to it in a truck and do something, right? But you prepare for these instances, and so you build your servers, as we're doing, with security built into the operating system, security built into the physical hardware, and security built in by its location, which benefits both commercial and defense for different reasons, but gets to the same place.
So no sector is particularly leading the way in that respect?
No, in that respect, no.
Okay. And obviously you're rubbing shoulders with some pretty massive players out there, the Googles, and Amazons of the world. Some of the other names that were mentioned were Grok and Relativity Space. And so how does Sophia, muscle in there with these elephants dancing around?
We don't have to muscle in. This is always a funny conversation, because this is very much like, like, as I said, I've been doing entrepreneurial work for 30 years. And this is a conversation we had in the 90s with Google. Like, why are you doing that if Google's around? Google can do that too. I'm like, no, yeah, I know. Right. So, but it's actually kind of fine. Like, a lot of the companies that the bigger players that we're talking about, a lot of them are doing, just vertical infrastructures for their own purposes, or vertical infrastructures for their specific client purposes. We're more of a horizontal play. right? So we service everybody, and we think we have an amazing solution to several problems in this step of the equation that other people don't. And so it's not a matter of viewing the Googles of the world, the SpaceXs of the world as competition. It's a matter of viewing them as partners or potential customers, right, going forward. And that's the tack that we've taken, and it's been received very well.
And I know some of the things that are going on are confidential, but what can you tell me about what's next for Sophia?
What's next for Sophia is we are in our current funding round that'll get closed out fairly quickly, and we begin the process. We've already got the components that we need are created, and so the next year to 2 years is building up our customer pipeline and firming everything up and getting ready for what comes next. You're right. There's a lot I can't talk about, but we are taking computers into orbit and taking data centers to the next logical location.
And where can people find out more about Sophia?
You can go to Sophia.space. And I keep pointing at .com, but there's no .com. Sophia.space, and find out all about us. We've been getting a lot of press lately, so you can also search for us on the web. All of that will come up, and you can find me on LinkedIn if you want. LinkedIn, Rob DeMillo, I think, is my LinkedIn handle.
Rob, thank you for your time. Let me talk us out here. So I want to thank the Mobile Satellite Users Association for hosting these sessions. You can learn more about the MSUA at msua.org. You can learn how to get our weekly newsletter that gives you updates on everything that's happening in the industry and shares information about upcoming events. And you can also find out how to become a member. We look forward to seeing you next time on MSUA's Game Changers webcast. Rob, thanks again.
Roger, a pleasure. Thank you so much.
Okay.